Hi and welcome to my channel. My name is Magnus and today we're going to talk about network design. Actually about risk analyzing and risk mitigation and how to justify different network design and security considerations. So in the beginning of time or in the beginning of networking, we always had like flat networks. So we put the users and servers within the same network within the company. Everything was on-prem. So you more or less consider like everything behind the firewall inside the company was secure. And then you had the perimeter firewall to protect against the bad internet. But more or less, everything within the network was secure. And we all know that this is not really a good design, but more or less that's where everyone starts. And then someone said like, yeah, you shouldn't put your servers and your users together. And I fully agree with that. So the easiest way was just to move the servers. So we put the servers behind the firewall. So what happened when we did this? Well, first of all, we got a bunch of requests. So people started to need to do like firewall requests for everything. And depending on what sort of personality you have and what sort of company it was, because in many cases it's ended up with Office network, the server network allowed all ports. So more or less our firewall became a router with logging. And I would say this is still pretty common. So if we should do some risk analyzing and say like what is the potential damage or what is the potential risk of having a design like this? So one risk is of course like, yeah, we need to do firewall rules for everything. This can delay projects. We start to get like everyone blames the firewall instead of the network. But there is also other sort of risks. So what happens if someone attacks you from the outside? What if someone starts like a DDoS attack? So a DDoS attack doesn't need to be volumetric. A DDoS attack can of course be volumetric and then it fills up your internet connection or certain things. It's more or less sends enough traffic to crash your boxes. And then maybe some people say like, yeah, we only have 100 megs internet and internally it's 1 gig or 10 gig. But you could actually send like 1 million connections on like 5 megabit. Can your firewall cope with 1 million connections per second? I don't think so. So more or less you can kill the firewall with external attacks. It doesn't really matter what it is. And what happens if you do like this is that the users can no longer access the servers. So what if this is a manufacturer, a factory, and they need to access like drawings to the robots to be able to build stuff? Then the production stops. So it's not only that your website or so on is not like accessible from the internet. More stuff is actually happening when it happens like this. So this is something that you should consider when you're building your network. So I don't say that this is a good design, but there are people that have this design and this is quite common design actually. So you have your perimeter firewall or your internet firewall and then you place all your DMZ servers, like servers that need to be accessible from the internet behind this firewall. And then you have like routed networks, more or less. You have some sort of, I don't want to call it segmentation, but you divide it up so it's partly segmented. I mean, you have different VLANs, you have different subnets to reach your production servers. So if we take the same scenario, okay, someone is DDoSing us. Okay, this box go down. Okay, our external website doesn't work. So that has different risk, like, yeah, we cannot get new orders, but our production maybe still works. But there are also other risks that you need to consider when you're having a design like this as well. So what if you get an infected host? Okay, and we have our flat network. It's still a flat network even if it's routed. It's like free for all within the corporation. So this bot is trying to access resources. And maybe it infects one server, all servers, or all like users, endpoints within your corporation. So this is something that you should consider as well. And even if you put like a firewall like this, okay, you can have the same scenario. So you still have the DDoS, they kill the box, okay, we're still fine. We get an infected host. So let's say we have a really nice advanced firewall and we haven't built our firewall rules on ports and IP addresses. Because if we have built our firewall rules on ports and IP addresses, the firewall, internal firewall, will it actually block like a ransomware attack? I mean, check your own rules. How does it look from your office network or your network to your internal production servers? Do you use something else than IP addresses? You should do, but do you actually do it? But let's assume that we are using identity-based firewall rules. So this specific infected machine couldn't reach the production servers. I mean, it was an infected machine for something else. Let's just assume that. But if you don't build your network in a way so the infected machine cannot reach stuff on the local LAN, you still end up with a bunch of bots or a bunch of infected machines, and over time they will reach stuff in your production service, in your DMZ. They could be used for like, well, they could be used for attacks for other things. And it's not like it was before when like ransomwares, they infected a machine and they start to encrypted stuff and they send the crypto key out to the internet. That's not how ransomware works anymore. So how malware and bots and ransomware or whatever, they try to spread laterally. So they try to spread across the network and infect as much as possible to gain as much access as possible. Then they try to extract your data. So they send your data to something externally. And when they have done that, and when they have lured around in the network as long as possible, then they start to encrypt your files. So what is the reason for this? Well, if you can gain as much access as possible within the company, you can inflict more damage. You increase the likelihood of someone paying a ransom. But not only that, you destroy the backups. And you also get out as much data as possible. What can you do with data? You can sell the data. Or you can threaten someone to extort them. We will publish your data online, free for use. So all your patent secret data, it's online. So even if you could restore everything and get back to normal, they still have your data. They can do whatever they want with their data. And if they are really nasty, they take your data, they check in it and see, oh, we have these vendors, we have these customers. So they start to talk to your customers that you have data for. So you need to think a few steps more. So even if you have like internal firewall or internet firewall, it also depends on what sort of rule base do you have, what sort of protection do you have. And I know this is a very checkpoint specific channel and we have mostly talked about like firewalls, but you need to have endpoint protection. you need to have a bunch of more security features, because security works in a layer. So it's not enough to only have firewall. Even if you have IPS, antibot or whatever, that's not enough. You need to have endpoint protection. You need to have centralized logging. You need to have a CM system. You need to have a bunch of things. So the risk analysis that you should do when you're implementing or when you're building something, this should take up a bunch of things, and you should put the risks on this and what we do to mitigate this risk and what is left. And then you can use this to justify additional budget. You can use this to justify what you're actually saying, because money talks. But let's move on. So we have this network diagram. We still have the internal firewall. We have an internet firewall. We have separate our production servers from our DMZ servers. Okay. So we need to expand. We need to expand our production servers. Okay. So we add some additional VLANs. And to get the throughput that we need. Because remember, in this case, all the production servers, they can talk locally. If they are the same VLAN, they can talk locally, wire speed. If we need additional servers and we want to segment them up in different VLANs for different functions or different servers or whatever, different applications maybe. If we add a router like this, we still more or less have wire speed. We can do this like locally within a layer 3 switch or within Cisco ASI or whatever. But what happens if one of the production servers get infected? This will also spread laterally. Because if you have a router, you don't really have any inspection points. You don't really have any rules to limit the traffic between the segments. So what is the reason why you do this? Normally it's due to cost. A firewall, to act as a default gateway for everything, needs to be really scalable. And it will cost money because performance costs money. But let's assume we don't care about that. What if we have a test system and tests shouldn't reach production? I mean, it's really bad if test data comes into the production system. The other way around is maybe fine, but test data in your production system is not a good thing. So we do like this. We use the internal firewall as default gateway for all our server networks. So what do we need to consider when we have like this? Well, first of all, we have the firewall performance. If you have checked like a layer 3 switch, 10 gigabit or whatever, you see it's quite reasonable. It's not really a problem to route traffic within 10 gig. If you check the same spec for a real firewall with full level 7 inspection, this needs to go in CPU. This is expensive. So the first concern is cost. So you need to be able to justify the cost of doing this design. And then we have the rule base itself. This gets quite complicated fast. So we have the rapid changes, and we're not even in public cloud here. So if we're talking about like on-prem stuff, you still need to be able to, let's say, make firewall rules daily. Let's just assume daily. And when you start to add servers, it gets more and more and more. So the scale of the rule base, like how should you build the rule base so it's actually visible? There is a bunch of people, or more or less everyone, they want you to make openings. But actually think about how many have asked you to remove something. It's not so common if I say it like this. So you need to consider, yeah, should I put the DMZ rules first or last, or should I put this? this application, or how should I do it? So the scale of the rule base has impact on your performance, have impacts on your ability to do rapid changes. It has impact on your how human readable is it. So there is a bunch of things to consider here. And when we talk about server-to-server communication, we also need to consider like how much knowledge do the application owners have? And that's assuming that you work in a large enough company with application owners. Not everyone doing that. So it could be up to you to figure out like how this application is actually working. And this gets more and more important if you upgrade applications, you scale applications. So this combination can become, actually it becomes like, yeah, it's a firewall issue. It's always the firewall issue. Before it was the network, now it's always the firewall. Because we're starting to implement more and more security features, and it's always some limitation, we always forget something because rapid changes limit the lack of application knowledge and the scale of the rule base itself. But not only that, we also need to consider scalability in form of the boxes. How big box should you buy? So the problem is like this. If you buy too big box from start, it's hard to justify the cost. If you don't fill up to a certain, like, if you don't use the box enough, your current applications are starting to cost more. Because normally you take the cost of the box and you divide it up in customers, systems, applications, or whatever. So you see like, yeah, this is the cost per application, per customer, or per something of this box. So you need to have certain amount of utilization, or at least you have calculated with some utilization, because that's how you decide how big box you want to have. So there are possibilities to work around this. So you can have virtual boxes, you can run V6, you can run Maestro, you can run it in public cloud, so you can go up and down in scalability. But scalability when it comes to on-prem, and when you don't know all the variables, because you can never know, you can only make a prediction based on the number of data points that you have. So if you're coming from something like, yeah, everything's going internally, it doesn't pass a firewall, we don't know what applications we have, we don't know how the servers are talking, it's not easy. And this is something that we still need to consider. So we can do an estimated guess. But other than this, so we have this network. And you say like, yeah, but Magnus, networks doesn't look like this anymore. Yeah, I know. So we have remote workers. We have applications in the cloud. And we want to have security for the cloud. And we want to have integrations between on-prem and public cloud. And our users want to access the public cloud directly because you don't want to send in the traffic to on-prem and turn around to go to the external. So there is a bunch of things. And even here, if we want to have, let's say, the production server network want to talk to Azure. So we have the firewall. We actually have 3 firewalls in this path. So if we go back here, we have internal firewall, internet firewall, and Azure firewall. So that's 3 boxes. So we need to make a firewall rule in all of them. So here it also comes with like rule placement within the organization. Should I have, yeah, I have this server. I have this rule in firewall A, B, and C. Not really efficient. So you need to decide like, where should I put the rules? Who is in charge of what? how should I build it logically? And if you're putting firewall rules everywhere, it's really error prone. So this is something that you need to consider right away. But even if we go back to this part then, so you see I've removed something from the drawing. So I removed the user. Because within the network, we have a bunch more stuff. So we have printers, we have security cameras, we have coffee machines, even light bulbs. And when I say users, we have laptops, we have cell phones. So we have a bunch more things, and this gets more and more. So we need to have a design that actually consider all the different things that we have within the network. Because we don't want, if something gets infected within the network, let's say the coffee machine. Are you controlling the coffee machine? Are you patching the coffee machine? But maybe the coffee machine has like a little web service that's sending to the vendor, to the manufacturer, say, the coffee machine needs cleaning. And then they send the person there. So all of these equipment nowadays, they get smarter and smarter. I mean, the printer should be able to order their ink. Because you don't want to order the ink. This should happen automatically. But that means that the printer needs to have connectivity. It needs to be connected to the internet. It needs to be able to send something out. And honestly, when it comes to like IoT or products like this, security is maybe not the first in mind, maybe not the second in mind either. So we need to design the network around the premise that these things needs to be in our network, but they shouldn't reach everything. So the idea of this series is to make you think, is to make you print down different risks that you have within your organization and give you an idea on how you could build your network and how you build your network to limit risks. And because you limit risk of something and you build the network in a specific way, you can justify cost. Because even if you have the best design ever, if you cannot justify the design, mainly on cost, let's just be honest, cost is one of the trickiest things. And secondly, it's time. Or time could be first and then cost second. It depends on which sort of company you're in. But time and money. You need to be able to explain why you do certain things. So this was probably the longest introduction video to a series. But I hope to see you in the next one. Take care. Thank you. Bye.